Okay, this is a brief video about vectors and their scalars. Scalars simply mean we're going to scale the vectors. So here's our first example. We're going to do it by drawing. So we've been given G. I didn't write it down here, but I'll do it now. So this is the vector G, and it is 2 in the x direction and 2 in the y direction. So we want to draw these three vectors. Now when we draw these on the homework, make sure that you follow exactly where you're instructed to start the vector and the order that you do them in. Otherwise it won't auto-grade. So this one, as in any vector except for all the homework, we can draw it at any place. So this is going to be twice as big. That simply means that instead of going 2 in the x direction, I'll go 4. So I'm just randomly picking this spot here, and I'm going to go 4 in this direction. And let's see, 1, 2, 3, 4, and then 4 in this direction here, the y direction. 1, 2, 3, 4. Here's my terminal. I go ahead and draw my vector and label it. So this one is vector A. Okay, the next example is vector K. Vector K is 1/4 that of G. And so if we take 1/4 of 2, that's a half. So I'm going to start here and just go over half. And then it is also half going up, so it's about here. And so I'm going to draw my vector. It's about like that. There's my vector. This is vector K. And then finally, we're going to go ahead and do a vector. You'll notice something interesting about doing a negative. This time you'll notice that if I do -2 times 2, it's going to be, so I'll start it right here, it's going to be a -4. So 1, 2, 3, 4, and then if I times that -2 by the other direction, the y, it's also going to be -4. It's 1, 2, 3, 4. Here's my terminal. So starts on the initial, comes down to the terminal. You should notice that vector y is exactly opposite of vector A. Then they're kind of related here. Okay, that's how to draw vectors. Remember, on the homework, make sure you draw as instructed. All right, now for the next example. Next example would be, let's say I haven't been given a graph, but rather I'm going to be given a component form. This is actually pretty straightforward. So here's my example. R equals -2 and 6 is the component form. S is going to be 3 times that of R. Okay, so let's start out with doing the vector or the component form of S. So simply we take -2 and we times it by 3. So this would be -6. And then we times -6 by 3, which gives us 18. There's the component form. Now I'm going to go ahead and back here, just like we've done in previous units, and find the exact magnitude of vector r. We'll notice something really interesting. So remember that we take the square root of 2, that'd be -2 squared, making sure that I have parentheses around it, plus 6 squared. The inside here equals 40, and so this would be the square root of 40. Punch it in the calculator, and we get an approximate value of 6.32. It goes on quite a ways. There we go. Now, we do something similar with the vector s. This time we'll do the square root of 6 squared plus 18 squared, and that ends up being 360 in the square root. So there's the exact answer. And then the last part here, we're going to do the approximate, which gives us, punch that in the calculator, and I get 18.97. Now what's really interesting about this is if I went and times this when I had it in the calculator by 3, I actually get, and my rounded one is slightly different, but if I hadn't rounded it, I would have gotten exactly the same thing, 18.97. And so I can apply the scaling to the vector. Here, I would caution you, however, of scaling the inside of the square root. That doesn't quite work the same way. So make sure you do it when you get to the end of if you're going to do it that method. All right, so there you go. That should get you through the homework on 12.1. Happy math hunting.